Okay, so we're going to be reviewing our financial math section. This is for the third exam for this course. So first we're going to start off by talking about simple interest, which was the first formula that we learned in this section. And it's that our interest, I, is equal to our principal times our annual interest rate times our time. We have that you deposit $1,000 into an account earning 4% annual interest. Determine the amount in the account using simple interest if you let it sit for, and then we have a couple different times. So we can just plug this right into our simple interest formula. We've got I is equal to our principal in this problem would be 1,000 times our interest rate, so 0.04, times the number of years. Well, if we have 1 month passed, out of 12 months for a year, this is going to be 1/12 of a year. And we multiply this together, we end up getting that I is equal to 3.33 if we round to the nearest cent, which means the amount that we have in the account is going to be 1,000 plus this 3.33, so 1,003.33 for that first one. All right, for B, we have 9 months, and we basically go through the same process. So we've got the interest is equal to 1,000 times our interest rate, 0.04. And now our time is 9 months. Well, that's 9 months out of the year, or 3/4 of a year. You could just take 9 divided by 12 and simplify to 3/4. And you can type this into your calculator and end up getting 30. And so the amount that we have in the account after these 9 months is going to be 1,000 plus 30, so $1,030. And we just go through the same thing again. So we've got interest is equal to 1,000, 0.04. This time it's for 1 year, and we end up getting $40. So the amount that we have in the account is going to be 1,040, right? And then if we had 6 years, we would do I is equal to 1,000 times 0.04 times 6. And we end up getting 240. And so the amount that we have in the account is going to be $1,240, right? So that's simple interest. It's pretty, hopefully pretty simple. The next thing we learned was compound interest. So here we have that the amount that we have in the account is going to be equal to the principal, P, times, we have 1 plus R over N raised to the N times T. So next example is basically the same example, but now we're compounding interest instead of using simple interest. And then we can kind of compare and contrast what's going on. So for this first one, we're letting it sit for 1 month, and we're compounding monthly. So we can set up our simple interest formula, or not simple interest, compound interest. We've got that the amount in the account is going to be equal to our principal, or 1,000, times 1 plus our interest rate is 0.04. We're compounding monthly, so N is 12. And then we have this raised to the 12 times our number of years. Well, we're at 1 month again, so again, our number of years is 1 over 12. And so we can type this into a calculator, and you should end up getting this guy, which is actually the same answer that we got with simple interest after 1 month. And this makes sense because we've only compounded once. So there wasn't any intermediate compounding that happened, if you notice. So of course we're going to get the same answer because for simple interest, we compound essentially once. And over here in this example, we compounded once, because it was only 1 month and we're compounding monthly. For these other ones, we're going to get slightly different answers than what we got in the beginning, or for the simple interest. So this next one, we have 9 months compounded quarterly So we're going to set up our simple interest formula. A is equal to, our principal balance is 1,000. And we've got 1 plus 0.04 divided by n this time is going to be 4 because we're compounding quarterly. Raised to the 4 times, and here we put the number of years. Well, we're saying 9 months out of a year. So 9 months out of 12 months. So 3/4 of a year is how many years have gone by when we're talking about 9 months. And so we can type this into a calculator. Notice this 4 times 3/4. This simplifies to 3. But you can just type the whole thing into your calculator if you really want to. And we end up getting that this is equal to 1,030.30 cents. So slightly different than what we had for simple interest. It's very, very, very close, within 30 cents, but it's slightly different. And then this last one, we have 6 years compounded semi-annually, and we can just plug into our simple interest or compound interest formula. So A is equal to our principal times 1 plus 0.04 divided by, here we're compounding semi-annually. That means twice each year. We raise that to the 2 times t, which is 6 years this time. And now we can plug this all into a calculator and get $1,268.24. And so this is the amount in the account. Now it's more, $8.24 difference than the simple interest formula. So very similar, but slight difference. All right, now the next thing that we went over was savings annuities. And basically, a savings annuity is when we're basically going to start with no money. So this is our start with $0. And we're going to have periodic activity happening into this account. So I'm going to, with this example, talk as if it's monthly, but just keep in the back of your head, it could be quarterly, it could be daily, it could be semi-annually. But let's say the first month, we're going to go ahead and deposit some money, and that's going to be our D. And so we get this money right here. And then the next month, we're going to deposit some more money, and it's going to be the same D. And since we had money in the account, interest is also going to accumulate based off of our interest rate R and how frequently we're compounding and stuff like that. And this is basically going to happen again and again and again, and we're going to build up a savings. And A is going to be the amount that we have in the account after however long we've been saving up, right? So this is the general concept of a savings annuity. We're depositing money into the account, growing the savings, and interest is also accumulating money in the account, right? And so we have this formula where the amount in the account at the end of our savings is equal to, this D is going to be the amount that we're depositing each period, times the quantity 1 plus R over N raised to the N times T minus 1, all divided by R over N. All right, so for example, suppose we want to save up $10,000 over the next 12 months. If we deposit regularly into an account earning 5% annual interest each month, we want to figure out how large our deposits should be. So we can set this up with the savings annuity formula. We know that we want to save up $10,000, so our A is going to be $10,000. We're trying to figure out how large our deposits should be, so D is the thing that we're solving for. And then we have this 1 plus, our interest rate is 5%, so 0.05, divided by, we're talking each month. So we know N is going to be 12, activity is happening monthly, raised to the 12 times the amount of years If we're talking about over the next 12 months, that's going to be 1 year. And then we have minus 1 divided by 0.05 divided by 12. All right, so here, if you were using the TVM calculator, you could plug this information in. You wouldn't even need to set up this formula. However, on your exam, you're going to have to know the formula, and you're going to have to use a calculator to be able to figure out what D is. So what I would recommend doing first would be plugging in what's inside of these brackets into the calculator. Now, if you do that, and please check that you do actually get what I'm about to write so that you know if you need to, make adjustments with how you're typing things in. You should end up getting 0.05116189.3. And so you can type that into the calculator and just write it down. And so now we're at this situation. Notice, let me just highlight this. So that yellow highlight turned into that other yellow highlight. If you multiply both sides by this 0.05 divided by 12, and then you divide by what's in these brackets, so we're going to divide by that guy as well. We're basically going to pull things away from D. So we get that D is going to be equal to this $10,000 times 0.05 divided by 12 divided by this decimal, 0.05116189.3. And so this you can type into your calculator, and you should end up getting $814.41. So basically, if we want to save up this $10,000 over the next 12 months, we should put aside $814.41 each month. It's how much we should be putting into the account. All right. Next, we went over payout annuities. These are kind of the counter to savings annuities. So these ones, you start with some lump of money, right? We start with P. And instead of depositing money, we're going to be removing money. Usually from a withdrawal. Later when we talk about loans, it's going to be payments. But basically, we're decreasing the balance by D amount. And this is happening each period. So you do that again and again and again each time that we come across another period. And then at the same time, interest is accruing in the account. And this is happening each time. So each period we're withdrawing money or making payments on, for instance, a loan. And then each period, interest is accumulating in the account, right? So interest is making the account go larger, and our withdrawals or our payments are making the account go smaller. And eventually, we're going to bring this account down to zero. So it's kind of like exactly the opposite of what's happening with a savings annuity. So one example of this would be a retirement account. So suppose we want to retire with enough money to support monthly withdrawals of $2,000, and we want to figure out the amount that we need to have saved up where the account's interest rate is 7% to support this, and we're assuming that we want this money to last us 25 years. So we can set up the formula. We've got that the principal balance, which is what we're trying to figure out, is equal to our monthly withdrawals, so $2,000, times 1 minus 1 plus our interest rate is 0.07, divided by 12 because we have activity happening monthly, to the negative 12 times 25 because we're doing this for 25 years. And then we divide everything by 0.07 divided by 12. Now there's no rearranging that needs to happen here. You can just plug this into your calculator. You might want to do it in pieces. But make sure that you plug this in and make sure that you end up getting this guy. If you do not get this guy, please, please, please send me a message on Canvas, or go and see the tutors. Get help before the exam in typing things into the calculator. All right. Next we have loans and mortgages. You do have a taxes homework that's going to be due soon. Actually, I say soon, but next week. That is not going to be on the exam. So this is basically finishing off what is going to be on the exam. So if you felt solid so far, you're going to be pretty solid for the exam. Loans and mortgages, you're going to end up treating them just like payout annuities, where instead of talking about withdrawals, we're going to be talking about payments. So if you think about that lump sum of money, when we were taking out withdrawals, talking about like retirement accounts, that's the same type of concept as making payments on a loan. You're decreasing the balance. So suppose we have $1,500 on a credit card with a 30% APR. We want to figure out what our monthly payments would have to be to have a balance of 0 over the next 6 months. So we're going to set up the payout annuities formula, where our principal balance is $1,500. D is what we're going to be solving for. Those are going to be our monthly payments. And then we have 1 plus 0.3 for a 30% APR. Remember, APR is the annual percentage rate. That's your yearly interest rate. We're talking about monthly payments, so N is going to be 12. And this is raised to the negative 12 times, we're talking 6 months. T has a unit of years. 6 months is 1/2 of a year. So we'll put 1/2 there. And then the whole thing divided by 0.3 divided by 12 again. So if you end up solving for D, which I highly recommend you go ahead and try to do, because I think when students make mistakes with these problems, usually it's with typing things into the calculator, you should end up getting that D is equal to $272.32. This is all that the question was asking for us to solve for, but I just want to make a couple comments. If we try to calculate the total that we end up paying over these 6 months, you can take the 272.32 and multiply by 6, because you're making 6 payments, right? They're monthly payments. And you'll end up getting that the amount that you spend in total is $1,633.92. And from this, knowing that the original amount that we owed was $1,500, you can subtract and get that the interest that we ended up paying on that account would be $133.92. So make sure you remember how to calculate the interest this way. You might get a question like that on the exam. All right, the last example. Suppose you decide to purchase a $350,000 home. And we're just going to kind of run through a couple different questions that you might be asked. So one of them is, you can afford to put $10,000 down. What percent down is that? For this one, you're just trying to figure out $10,000 is what percent of $350,000, and you'll just divide. So we've got $10,000 divided by $350,000. That simplifies to 1 divided by 35, which if we round to the 10th place, this is going to be 2.9%. So you put 2.9% down. All right, next we take out a 30-year mortgage with a 6% interest rate. How much are your monthly payments? This you treat just like a loan, which is a payout annuity. So we have our original balance, or our principal, is going to be that $350,000, and you're going to subtract off the down payment of $10,000. So the principal is going to be $340,000. And then you're just going to plug everything else into the formula. So we have D times 1 minus 1 plus 0.06 divided by 12, because we're doing monthly payments, to the negative 12 times 30. And then we divide by 0.06 divided by 12. And you'll go through that same kind of routine of solving for D. If you plug in everything correctly, you should get that D is equal to $2,038.47. So that's going to be your monthly payment on that mortgage. And then it asks, what do we end up paying in total for the home? Well, we're making these monthly payments every month for 30 years, and so we can just figure this out using some multiplication. So the total ends up being this $2,038.47. We multiply by 12 months per year times 30 years. And if you type that into your calculator, you end up getting $733,000. Oh, I'm saying dollars. $733,849.20. And if you wanted to calculate the amount of interest that you ended up paying on that home, you would take this number and subtract off the original cost of the home, which is that 300, or the amount that you took out on the loan, which would be the $340,000.